Okay, so let's try and convert this into code. So we know that each of our pieces are going to have, well, let me scroll to the right. I have to manually do it. Okay. Okay. Each of our pieces, I don't even need this function. I'm using this as like a getter and setter, but that's unnecessary. Anyways, oops, tablet out of the way. We know that each piece is going to have a get possible squares function. We also know, let's see, we've got this selector and start position property. I just want to add that here. Let's do this dot start position equals an empty string, and then this dot selector equals I don't know, just empty jQuery object. So this get possible squares, I guess first let's say this will take in what is the square we're trying to land on, right? Let's just call that the target. And we'll also have get interim squares. Let's just say get squares, get in between squares. And this will compare what is our current position, what is our target, and what is the direction we're attempting to move. So I guess another thing I want to do is I was thinking like I kind of want an enumerator that has each of these directions. So how would I want to do that? So I've got this const pieces up here. What if I also have const directions? I said enumerator, it's really an object. I'm just treating it like an enumerator. So let's say like n for north, and that value is 0. Northeast is 1. East is 2. Oops. Southeast is 3. South is 4. Southwest is 5. West is 6. And the northwest, 7. Okay. So this get in between square will be what is our target and what is our direction, which is going to be one of these values. So like direction.n should return 0. You might be saying, well, don't we need a notion of the current square we're on? And the idea is that this moves array. So if I go back over here, let's go back over here. Let me inspect this. The way this is set up is you'll notice that I have an array that keeps track of all of the moves that this piece has made. So the last move in this array should be the square that they're currently on, right? The nice thing about doing it this way is, you know, this will tell us both, it'll tell us the number of movements that this piece has made as well as everywhere that it's been. So get in between squares. And then we also want this is square occupied method. However, it doesn't make sense to have this function in this piece class or one of its children classes, because this is square occupied. This logic really isn't behavior that describes one of the pieces. It's really, if we were, if I was following true object-oriented principles, I should have a class for the board, and potentially this method lives on the board. But right now everything is just kind of hanging out in the open. So I'm just going to add a function and just call it square is occupied, and then it takes in a coordinate. Okay, and it will return a Boolean. So I'm really using these as like abstract methods, because the hope is that each of the classes that inherit this will override these functions. So for example, the get possible squares for the pawn are what? Let's return to this and do a little more doodling. Because I want to visualize the logic. Let's get rid of all these annotations. Get rid of that. Get rid of that. Let's get rid of our additional bishop. We've clicked on our pawn. Let's get the possible squares this could move to relative to its current square. So what I'm going to do is I'm going to have, in parentheses here, I'm just going to say how many squares do we have to move this on the x-axis to get to this square. We have to move it -1 on the x-axis, right? That's a possible square. How do I get to the square? If, how many squares up do I have to go? And that'd be 1. So this, to get to this square, I move this piece 0 on the x-axis, 1 on the y. To get to this square, I move 1 on the x-axis, 1 on the y-axis. To get to this square, it's 0, 2, right? So what we can do is try and get all of each of these squares by for example, let's see. So this is what, D2? So subtract 1 from D. So in other words, subtract 1 from here on the grid. So get the substring before that, which is C. And then add 1 to this value. So subtract 1 from this value, add 1 to this value, I should get that square. I should get C3, right? So let's do it. I'm just going to have this on the right here. Scroll down to where my classes are. Get possible squares. So first I'm going to do, let's do let current square equals what? It's going to be the last item in this moves array. So it's going to be moves, and then moves dot length. Oh, good call. This dot moves. This dot moves. This dot moves dot length minus 1. There's got to be a, let me see. There's got to be, oops, what did I just do? So I don't have to do this manually. The reason I don't want to do it manually is there's going to be, okay. There isn't a function for it necessarily, but this top one is doing it exactly the same way that I am. So let's not worry about it. Close this. Okay. But what if this dot moves dot length is 0? What if it hasn't moved yet? Do we have a start position? So if this is nothing, let's say this dot moves dot length is greater than 0. And if it is, then we do this dot moves. So moves at length minus 1. Otherwise, we know if it hasn't moved at all, it's at its starting position. This dot start position. So that should give us the current square. So let's check and see if that method worked, first of all. And the data for each of these pieces is saved in this piece array. So piece array.0. Oh, I actually want to log the current square. So piece array.0 dot get possible squares. Well, let me actually test this with the epon because that's the one that we've been kind of playing with. So where's my epon? My epon is actually our 8th item in this array. So let's do piece array 8 dot get possible squares. See what that gives me. Right now it should just return the current square. Okay, so it's giving me E2. Good. What if I move it? Now it's giving me E3. Cool. However, remember how earlier we were talking about how the actual jQuery data for this object for E2 pawn piece is not the same object as that one in our array. So let's see what that object looks like then. e2-pawn.data. See what that looks like. Okay, so it's still keeping track of it. So we're still saving that to the data array, or to the jQuery data object for this piece. And I think that's because, let me see, the move piece, the data. Let me get rid of these comments real quick, because I don't care about these two. So it's saving it. Piece data to add move. Okay, so maybe that notion of them being decoupled isn't actually true. I'm not going to worry about that right now. So we're getting our current square. So relative to our current square, we want to get the possible squares. So relative to E2, we want to get D3, E2, or sorry, E3, E4, F3. So let's say let possible squares equals an empty array. And I'm going to say possible squares dot push, and I literally want to get the text C3, or in this case, sorry, if we're coming from the perspective of our ePawn, I really want to get D3, which is this square, the text D3. So how do we do that? We will we really want to convert this into a number, right? So if this is E, this should really be, if this is the, we want to convert the file into a number in order to do this, because we just want to do some simple addition and subtraction, right? But this is an E, the E file should really be what? Should really be 0, 1, 2, 3, 4. This should be 4, 1 if it's 0 based. 4, 1. So let's say what's a quick way of doing that with how I currently have everything set up? Let's say current square equals what? What I want to do is say like grid dot get index of like D, right? -1. Let me just try that and see. So say that the current square is actually grid dot toLower dot index of I'm going to end up changing this, but let's just try this and see. probably making this harder than it needs to be. I just want to make sure that my head's in the right place. See what that gives me. So based on this, calling current square on this piece, I would expect to give me its location in the x direction, which is 0, 1, 2, 3, 4, and its location in the y, which is 0, 1, 2. So what, 4 and 2? Or I guess 4 and 3, 0, 1, 2. Why is it? Oh, I know why. Because we're not, this isn't zero base. This is actually its location in algebraic notation. So let's do this. Let's do this. So I'm going to say current square x equals, whoop. Let's do current square y equals -1. Okay. And now let's log this. Now let's log. Oops. Nope. There we go. Now I should expect this to give me 4, 2. What did I do? Oh, I have to do let. Let. We didn't declare those variables. I want this to be 1. 4, 1. 4, 2. Okay. So starting at 0, if this square right here, I'm really trying to convert. All I'm doing here is converting the algebraic notation of the square into actual physical coordinates, where 0, 0 is the bottom left and 0, 7 is the bottom right. Or sorry, it would be 7, 0 is the bottom right. So let's actually have a function to do just this. I'm going to say that the name of this function is function convert algebraic to coordinate. It's going to take in the algebraic and return what do we want it to return? Do we want it to return a two-dimensional array? Like, do we want this to be 4, 2 like that? Or I guess that wouldn't actually be a two-dimensional array. A two-dimensional array would really be 4, 2 like this. So ignore that. That's a two-dimensional array, right? An array of arrays. I think just returning an array would be fine. So can we make this shorter? Let's just say return an array where the first element is that, and the second element is this. Are we going to run into issues if we try and do this with this square? Maybe. Let's see. Let's get this working with the one that we're testing with first before we try and tackle those edge cases, which aren't really edge cases because that's still very important. So let's now use this. Let's do let chord equal convert algebraic to coordinate. And now let's just console.log our coordinate and make sure that that is giving us back what we expect to get. For 2. This should give me 4-3. Great. Cool. So we need to do some simple arithmeticing to get these possible squares. Which really what we want to have is, if the clean version of this is the square in algebraic notation, we might want the inverse of what we just did, right? Which is get algebraic from coordinate. So let's see. First, what I want to do is possible squares. Before we convert it back into coordinate or into algebraic, let's just do a possible square would be, let's say, I guess I was testing with D actually, not E. But in any event, let's subtract 1 from chord. So this possible squares is really going to be a two-dimensional array, potentially. So let's push an array where the first value in the array is chord at the 0 index -1, and then chord at the first index +1. All right. And we also want, okay, so let's now do just straight up 1. So what are we doing? We're not changing the direction on the x-axis. We're still changing it on the y-axis though. And then the next one is 1 and 1. So +1, +1. And then the last one is 0 on the x-axis, but 2 on the y. And let's see what that gives us. So before even moving it, what are the possible squares for this piece? It's giving us this square. Is that 3 and 2? 0, 1, 2, 3. 0, 1, 2, yeah. It's giving us 4 and 2. It's giving us 5 and 2. 0, 1, 2, 3. Wait a second. Wait. What's actually going to help me visualize this is, it's giving us 3 elements. But let's actually, just because, this might not be the most efficient, but it's going to be easier for me if we're actually returning the JSON object of each of these squares. So we're going to refactor this all later, but it's going to be easier if I have an array of the actual jQuery selectors for each of these squares. So how can I get that? Well, I already have a piece array that is that has all these pieces and those selectors. So can I get this from this array that I already have? I probably can. Probably can. So let's do this. I'm trying to think of the easiest way to do this. We can add a property here that is like the current coordinates, which is just an array of 0, 1, 2, 3, whatever it is, right? And then try and get that, get it that way. But we really already have a notion of its current position from either the start position or the last move. So I'm just thinking of how we want to actually convert these coordinates into these squares. So let's test this out. Let's say that we've got let our test equal a two-dimensional array of coordinates. So like 1, 2, 2, 3. Let's say that. And then let's also do, I'll zoom in here. 2, 3. So this array is really just an array of all the coordinates of our current pieces. Or of, not our current pieces, no, we don't care about our current pieces, we care about the current, any of the squares. No. So this piece array isn't going to help us necessarily because we want the coordinates of all of the pieces, right? So I could have a function that's like get square from coordinates. Let me just do that for now, right? Let's say function get square from coordinate. And it just takes in the coordinate, which is an array, a two-valued array. It's going to spit back the JSON version of that square. Not the most efficient way of doing it, but from, I guess, ease of use, to make it easier for me, it works for now. So we've already got a function convert algebraic to coordinate. So let's try this. How long are we going? 33. Let's try this. Let squares equal dot square dot ATR ID. This should give me don't these have the class square? Let me zoom out again. Get rid of that. What? What the heck? Yeah, it's giving me all the squares. Let's say square dot first dot attr ID. Why isn't it giving me the ID I'm of that square? Apparently I've looked this up. That's exactly what I did. That's exactly what I'm doing. So for example, the C3 square no. Oh. It's because it's giving me the template, huh? Hmm. How do I want to do this? How do I want to do this? Just give me one moment. Okay, I think I was making it too complicated. So what I just did is I added this convert coordinate to algebraic, which, remember, that coordinate is just going to look like a, I don't know, 1, 1, right? In that case, 1 and 1 would be this pawn. So convert coordinate to algebraic. Well, I guess let's try that. So let's just call that function and see what it gives me. Let's give it a 1, 1. B2, right? Easy. So now what I want to do is return. I want to get the actual jQuery version of that square. And I know that the ID is going to be B2, right? Get square from coordinate. So let's see what that gives me. Let's call it get square from coordinate. You just pass in an array with 1, 1. See what that gives me. Beautiful. Okay. So now I can use that here where I was saying, okay, here are the possible squares, right? And what I actually want to do is push get square from coordinate. Actually pass this in like that. So really just wrap this array that I'm making here in this function. Is that all in the right place? I think I have to manually just add the right parenthesis. Oh shoot, didn't want to add the parenthesis there. I meant to add it here. Okay. Now let's call get possible squares. Get possible squares. Okay. So it gave me boom, 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 boom. So this is for this piece. Boom, boom, boom. Okay. Those are all the possible squares for this pawn, for my D pawn. That's great. Square from coordinate. So now what we can do, for example, is let's say that let's return get possible squares. And then let's say that when I first click on a piece, where are my event listeners? Here. I'm just gonna minimize these classes and move them. Really, these should all be in separate files, right? But we didn't do it that way. So I think I'm actually gonna put these first. So when you click on a piece, if start click is null, or an empty string, that means that this is my first time clicking on it. Let's call this e.target.data, which should return our instance of that pawn class, where we can call what? Get possible squares. I think it's actually supposed to be, shoot. e.target.find. Oh no. We cancel that out real quick. I want to find the piece, right? e.target.find piece, which you'll look for all of the children elements of this square with that class piece, .data.get possible squares. What did this give me? Well, I guess first of all, let's just console.log this. Oh, I'm doing the same thing down here. Doing the exact same thing. Okay. That is the same. Let's go to that one. So I should have a method in here that is get possible squares, yeah? Data.get possible squares. I'm not calling the function, I'm just trying to get the definition of it. It's undefined. You're undefined. But why is that? Because when I look at what's returned here, it's obviously giving me the data object, right? And I can drill in and see that get possible squares function exists. Oh, is it just because I wasn't passing in the argument? Is that why? Get possible squares target. Let's say for now it doesn't take in a target. Let's say for now it doesn't take anything in. Is that why I was doing that? Data.get possible squares without an argument. That would be why. That would be why. Okay. So when I click on my dpawn, it gives me C3, D3, E3, D4. Great. Because that was my second click, it moved it. It moved the piece. So we'll need to reevaluate this logic. But what do we have? We have the logic to whenever we first click on a piece, we're at least returning an object with those destination squares. So let's just to try and preview this, let's do .add class bg-warning. Get rid of the console. Actually, I'll leave the console log. This is returning. Oh, it's because it's returning an array. It's not returning a jQuery object with all these objects in it. So let's do get possible squares. I'm just going to do. So don't worry about this. Just ignore this part. I'm just doing this to demonstrate what we did. Dot. See that? Refresh. Boom. 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 Does it work for the ones on the end? Yeah. Okay. In the next one, we will refactor this and try and extend the logic to the other pieces other than the night, because I don't know what we're going to do for the night. But we're making progress.